So in my last video I have explained about batch operating system. Now this is the second type of operating system, that is multi-programmed batch system. Okay, so multi-program batch system, multi-program batch system. In multi-program batch system, in batch system what happens when one process or one program is being executed and it is waiting for an input output event, then CPU will be idle. Okay, there will not be any other process bring into the CPU for the purpose of execution. Okay, CPU will be idle and it has to wait till this process finishes its input output operation and get back for the execution. But in case of multi-programming, when process is performing input output operation, the CPU can execute another process. When one process is executing and it is waiting for, after a certain time it goes under wait, or it is waiting for certain input output resources. When it goes under wait or waiting for certain input output resources, another process P2 can be bring in. Okay, this is called as multi-programming. It means what? Multiple program P1, P2, P3 like that, multiple program can execute in one CPU. Okay, so see here, the multi-programming operating system may run many programs on a single processor computer. On a single computer, many programs can be run. Okay, so this is basically non-primitive. There are two types, primitive and non-primitive. Primitive and non-primitive. Non-primitive is nothing but we cannot forcefully take out the process from CPU. If this is CPU and this is process 1 and this is waiting for certain input output operation, then we cannot forcefully, it is when it is being executed, we cannot forcefully take P1 out of the execution and we cannot put some other process P2 into the execution. We have to wait, either it should go under input output operation, some interrupt should arrive, or it should complete its execution, or it should be terminated. Till then we cannot take out process P1 from the CPU. So see here, if one program must wait for an input output transfer in a multi-programming operating system, the other program are ready to use the CPU. As a result, various jobs may share CPU time. Okay, it means what? As I have explained already, when one program is being executed and when input output request arrives, okay, then this process has to wait for to fulfill the input output request, right? So another process we can bring it into the CPU for execution. Okay, however, the execution of their job is not defined to be at the same time period. So execution will not perform at the same time period. Suppose like P1, P2 will not work simultaneously, not at a time. Okay, CPU will not execute both the program at a time, but when P1 is executing and when it goes under wait, then P2 will bring into the CPU for execution. Then after some time P2 will go for input output wait, then P1 can again enter the CPU. Concurrent program execution improves, here when a program is being performed, it is known as task, process or job. So program is nothing but task, process or job. This program what we are executing is only task or process, or you can call it as a job. Okay, concurrent program execution improves system resources consumption and throughput as compared to serial and batch processing system. In serial and batch processing system, what happens is when one process is executing and it is waiting for input output resources, then another process cannot execute. So but in case of multi-programming environment, the system resource consumption will be very efficient. When one program is executing, another process can use the CPU. The primary goal of multiprogramming is to manage the entire system resources. So I hope you understood what is multiprocessing. To understand it further clearly, I'll tell you what is uniprocessor. We must know what is uniprocessor. Okay, so when you will understand what is uniprocessor, then you will easily understand what is multiprocessor. So in uniprocessor, it start executing when the process has to wait for input output. So suppose there is a program 1, okay, and in uniprocessor environment, what happens, this process P1 is executing, okay, then it goes under wait. Then we cannot bring P2 into the memory, P2 into the execution. Once P1 has completed and it gets terminated, then only P2 can enter the processor for the purpose of execution. This is known as what? Uniprocessor environment. But when it comes to multiprocessor, suppose P1 is executing, okay, P1 is executing and it goes under wait, okay. When this is under wait, this is process P1, okay, this is being executed, okay. So P1, this is P2, this is process P2. So this P1 is executing means P2 has to wait, and when P1 is under wait, then P2 can execute, okay. When P1 gets back, then it can execute into the CPU. When P1 is executing, P2 has to wait. When we combine this, we can see P1 is executing, then P2 is executing. When P1 is waiting for an interrupt, then P2 can execute. Then it will wait for certain amount of time. Then again P1 will execute, P2, like this it will continue. This is called as what? Multiprocessor. Multiple programs, more than one programs can run at a time. Okay, I hope this is clear. Now moving to the next concept, types of multiprogramming operating system. Now we have seen what is multiprogramming operating system. There are two types under multiprogramming operating system. First one is multitasking operating system, multi-user operating system. So what is this multitasking and multi-user operating system? Multiple tasks will be performed. A multitasking operating system enables the execution of two or more programs at the same time. Multitasking is also known as time sharing operating system, that we will see in coming videos, okay, time sharing. So multitasking, what happens in multitasking is more than one program can be performed. So here we will provide a time slot that is known as time quantum. This time slot is also known as what? Time quantum. A multitasking operating system enables execution of two or more programs at the same time. So there will be a time slice, this time period which will be provided is known as time slot, time quantum or time slice. It will be of 5 milliseconds or 10 milliseconds. It is based on processor, okay. Here what happens, suppose there are more than one processes, P1, P2, P3, P4. Then each process, this process wants CPU for 10 milliseconds, this needs 5 milliseconds, this needs for 4 milliseconds, and this needs for 3 milliseconds. And the time quantum is of 3 milliseconds, okay. So what happens, first P1 came first, right? So P1 will execute for 3 milliseconds, okay. Then after 3 milliseconds, this process will be preempted and P2 will enter into execution, okay. What is the remaining time for P1? That is 7 milliseconds. P2 will execute for 3 milliseconds and remaining time for P2 is 2 milliseconds, okay. P3 will execute for 3 milliseconds, then remaining time is what? 1 millisecond, and P4 will complete its task. Then again P1 will enter, then P2, then P3, then again P1 like that until it completes its time required to execute till then it will be keep on entering into the system. Like this, every process will get equal amount of time for the execution. Okay, the operating system accomplished this by shifting each program into and out of memory one at a time. So this is what I told you. Okay, here every program will get some amount of time, like in seconds, milliseconds. Okay, once that time is reached, that threshold is reached, then CPU will operating system, what it will do, it will remove that process, particular process from the execution, and some other process will get into the execution. Okay, remaining time will be continued once one set of process have completed its execution. When a program is switched out of memory, it is temporarily saved onto the disk until it is required again. So once the program is been printed or taken out of the memory, it will be saved on what? Disk. This is nothing but secondary memory. You know that in order to be executed, program to be executed, it should be present in main memory. From secondary memory you cannot execute any program. Process cannot be executed from secondary memory. It should be bring into the main memory for execution. Understood? So next one is multi-user operating system. This is another type of multi-programming or operating batch system. Okay, so multi-user operating system allows many users to share a processing time on a powerful central computer from different terminals. So here multi-user system, system what happens in multi-user system is this is like a client server model. Okay, if you don't know what is client server model, I'll explain you what is client server model. There will be one processor and many terminals, or you can call as host, or system, PC, whatever you want to call it as. Okay, many terminals T1, T2, T3, many computers will be connected to one central processor. Okay, and all the computer can run at a time. The memory and the processing will be shared among many terminals. This is nothing but multiple user system, where multiple user can access to single node, central unit. Okay, central computer. Multi-user operating system allow many users to share processing time on a powerful central computer from different terminals. Okay, the operating system accomplishes this by rapidly switching between terminals, each of which receives a limited amount of processor time on the central computer. So this processing time rapidly, in the sense it will be continuously switching. Okay, so this processor time on the central computer, this will be so fast, so quick that terminal will think that a user feel that they are using a separate CPU or processor. Okay, the operating system changes among terminals so quickly, the same point quickly, that each user seems to have a continuous access to the central computer. Okay, I hope this is clear. This is like a client server model, where one system will be there, one central unit will be there. For that, many systems will be connected, and these systems can use the central computer simultaneously, continuously. Okay, now we will see working of the multiprogramming OS. First point is, multiple users can accomplish their job simultaneously in the multiprogramming system, and it can be stored in main memory. So this is nothing but summary of what we studied so far. What is I have already explained you what is multiprogramming, what is multiple user, multi-user, multitasking. I have already explained you these things. Okay, here we have summarized this. Okay, multiple user can accomplish their job simultaneously in the multiprogramming system, and it can be stored in main memory. Okay, first point is, Then second point is, when one program is engaged in input-output operation, the CPU may deliver time to various programs while sitting in idle mode. So CPU will not be idle, CPU will be always busy. Instead of sitting into the idle mode, what CPU will do, it will take some other process into the memory for the purpose of execution. Third point is, when one application is waiting for an input-output transfer, okay, another is ready to use the processor at all times, and numerous programs may share CPU time. So when process P1 is waiting for certain input-output operation, other processor in the queue can take up the CPU for execution. Okay, all jobs, if these processes are ready to be executed, then only it will enter into CPU. If this process needs certain input output resources, then it has to wait. If P2 wants certain input output resources at the same time, then it has to wait, then P3 can enter the CPU. All jobs will be run simultaneously, but there could be numerous jobs running on the processor at the same time, and part of the other process being executed first, then another segment, etc. So this will be executed segment wise. So P1 process is divided into many segments. Segment is nothing but part. So this part is executed. After this part is being executed, okay, to execute this second part, it needs certain operation to be performed. So it has to wait to perform next part. So this part has executed, so next part will be executing. Okay, so P2's one segment or part will be executing when this is waiting for certain input output operation. I hope it is clear. As a result, next point is, as a result, the overall goal of multi-programming system is to keep the CPU busy until some tasks are available in the job pool. Job pool is nothing but where all the processes will be residing, P1, P2, P3, P4. So this job process is known as job, task, process, program. It is one and the same. So this is nothing but where all the processes are residing, that is called as what? Job pool. Okay. So as a result, the overall goal of multiprogramming is what? Is to keep the CPU busy. Until there are processes into the job pool, CPU must be busy. Means what? There should be rapid switching between the processes. Thus, numerous programs can run on a single processor, computer, and CPU is never idle. So CPU will never be idle. So one or the other processes, until there are processes in the job pool, one or the another processor will be keep on executing into the CPU. So now we will see certain advantages of multi-programming operating systems. First one is, it provides less response time. So less response time means what? P1 is executing, right? So P2, P3, P4, there are so many processes into the system. P1 is executing, so it is waiting for certain event to it is waiting for certain input output resources. Okay, it need not has to, all the other processes need not has to wait till this P1 completes. If it is going under waiting condition, then P2 can execute, P3 can execute, P4 can execute. Like this, one or the other process can execute. So response time, it will be what? It require what? Less response time. Second one is, it may help to run various jobs in a single application simultaneously. So various jobs can be executed in a single application. Next is, various users may use the multi-programming system at once. So multi-programming is what? There is two types, right? One is multitasking and another one is multi-user. So various number of users can use the multi-programming system. Short time jobs are done quickly in comparison with long term jobs. So if P2 requires only 2 milliseconds, when it goes under wait, P2 can execute, right? Or when it comes to multitasking system, if the time quantum is of 2 milliseconds, then P1 will be preempted after 2 milliseconds and remaining time will be executed later on. So in that time, P2 can execute for 2 milliseconds. So this is shorter job, right? That will be executed. So this is what? Shorter time jobs are done quickly in comparison to long time jobs. It may helps to improve the turnaround time. So in my last video I had told you what is turnaround time. Turnaround time is the time when the process is admitted into the system till it releases. The total time is known as turnaround time. So it may help to improve the turnaround time for short time tasks. It helps in improving CPU utilization and never gets idle. So in multi-programming environment, CPU will never be idle. The resources are utilized smartly. So these are 7 advantages. You can write any 5 if asked in exam. Okay, next we will see disadvantages. So every system, when there are certain advantages, there are also certain disadvantages. Every system has advantages as well as some disadvantages. So it is highly complicated and sophisticated. So many processes will be there, so many processes will be running at a time, and there will be completely quick switch between all the processes. So this is what this becomes, this makes the system complicated and sophisticated. I have given example of only 3 processes, but in real there will be number of processes present. Okay, CPU scheduling is required. As there are many processes into the system, CPU must know, operating system must schedule which process will enter the CPU first. So there are different scheduling algorithm. In coming videos you can see it. Okay, such as round robin scheduling, first come first serve scheduling. There are many scheduling algorithms. Okay, based on that, process will enter into the CPU. Memory management is needed in this OS because all the types of tasks are stored in the main memory. So there will be quick switching between the memory, right? Primary to secondary to primary. So there should be enough space in main memory in order for a process to execute. The harder task is to handle all the process and tasks. There will be number of tasks present, so operating system must manage all the processes. Last one is, if it has a large number of jobs, the long term jobs will require a long wait. Suppose P1, P2, P3, P4, P5, there are number of jobs. Okay, in multitasking there will be time slice, but in actual multiprogramming environment, what happens, we cannot take CPU process out of the CPU, and this process P1 requires 10 milliseconds to execute, process P2 requires 2 milliseconds, 3 milliseconds. This requires very less time to execute. Then this first process requires 10 milliseconds to execute. Okay, suppose then this process P1 does not require any input output operation. It is not waiting for any input output operation. So P2 has to wait for 10 milliseconds to perform only 2 millisecond job. So this is what, if it has large number of jobs, then long term jobs will require a long wait. Okay, I hope it is clear. Thank you.